Welcome to Syeadh Academy. File Management in Operating System. File management is a crucial aspect of operating systems that involves handling files, organizing them, managing storage, and facilitating access to data stored on secondary storage devices. File system. The operating system provides a file system that defines the structure and organization of files on the storage devices. It includes metadata, such as file names, sizes, creation and modification timestamps, and permissions. File organization. Files are organized into directories or folders to create a hierarchical structure. Directories can contain both files and subdirectories, allowing for logical grouping and organization of related files. File operations. The operating system provides various operations to manipulate files, including creating, opening, reading, writing, closing, deleting, and renaming files. These operations are typically performed through system calls provided by the operating system's file management interface. File access control. The operating system enforces access control mechanisms to determine which users or processes have permission to access specific files. File permissions specify read, write, and execute permissions for different user categories, owner, group, and others, to protect the confidentiality and integrity of files. File storage. The operating system manages the allocation and storage of files on secondary storage devices, such as hard disk drives or solid-state drives. It tracks free and allocated storage blocks and ensures efficient use of disk space by grouping file data into contiguous or non-contiguous blocks. File allocation techniques. 1. Contiguous allocation. Files are stored as contiguous blocks on the disk. This technique allows for fast sequential access but can lead to fragmentation and inefficient space utilization. 2. Linked allocation. Files are divided into blocks, and each block contains a pointer to the next block in the file. This technique minimizes fragmentation but can result in slower access times. 3. Indexed allocation. A separate index block is used to store pointers to blocks containing the file's data. This technique allows for faster random access and efficient storage utilization. File caching. To improve performance, the operating system may employ file caching, where frequently accessed data is stored in memory to reduce disk access times. Caching mechanisms help minimize the number of disk reads and writes and enhance overall system responsiveness. File system integrity. The operating system ensures the integrity of the file system by maintaining file system consistency and performing regular disk checks and repairs. This helps detect and fix any errors or inconsistencies that may arise due to power failures, system crashes, or other unexpected events. File backup and recovery. Operating systems often provide mechanisms for file backup and recovery to protect against data loss. Backup tools and techniques allow users to create copies of files or entire file systems, while recovery mechanisms help restore files in the event of accidental deletion, hardware failures, or other data loss scenarios. Conclusion. Overall, the file management capabilities of an operating system enable users and applications to effectively organize, store, access, and manipulate files, ensuring data integrity, security, and efficient storage utilization.